The product property of a logarithm is very similar to this. Guys, what would you do with m and n? Yeah, same thing here. So for logs, log base b of m plus log base b of n is going to equal a single log of log base b to m times n. So any logs added with the same base, you can just multiply the arguments together. Just multiply them. So if we look at this example, we have write log base b of 5jk in expanded form, meaning as a sum or a difference. It's going to be a sum because it's multiplied. It would be a difference down here if it's division, which we're going to talk about. All right, so log base b, and then how many pieces make up that argument right there? How many things are there? There's 3. So you have to have 3 terms, guys. So your first term is log base b of 5 plus log base b of j plus log base b of k. So that's expanded form. You just got to write it all out. Everything gets a plus sign because everything is getting multiplied together. Here, this is already expanded out. I'm checking to make sure they have the same base, which they do. So I get to write it as a single log of log base b of 6x. And guys, remember, like I said, parentheses are super important. This is not a log plus a log. That's a single log. So remember, parentheses mean you can't break it apart. It's one log. Okay, now let's go ahead and talk about division. And you guys know that. If I had 2m over 2 to the n, we would go ahead and subtract those exponents. Anything below a fraction bar is negative. That's going to be the same exact thing for a log. So if I have log base b of m minus log base b of n, that's going to be a fraction. So that's going to be log base b of m over n. Anything below a fraction bar is negative, y'all. So on this example, underneath your box, here's a fraction. You know you're going to have a minus sign. We have 2 pieces that make up the argument. We have an x and we have a 2. We're going to have 2 terms when we expand this out. So this is going to be log base b of x minus, because the 2 is below a fraction bar, log base b of 2. All right, next one. So I'm checking to make sure they all have the same base. They have to have the same base. They do. So we're able to use our properties. I've got 3 terms here, guys. I have 2 terms that are positive, and I have 1 term that's negative, which means 2 things are going to be in the numerator. 1 thing is going to be in the denominator. So I'm going to go ahead and write log base b. And then what's in the numerator? I thought I heard somebody say it. Yeah, and then the z is down below. So look, again, you cannot simplify anything that's set in parentheses, and you also can't simplify and use product or quotient properties when the word log is in the denominator. If the word log is in the denominator, that is not what is happening for our quotient property. So be careful with that. Yes?
If log's just in the numerator, like if it was log bx, the whole thing over y, would you be able to simplify that?
Yeah, that goes to our very next page. Let's turn the page. All right. So by the way, this is it. I only have a few more things that I'm going to talk about for you today. And then we'll talk about that in a minute. Let's go ahead and look at the top of the page. All right. So for any positive real number x and b, b is not 1, for any real number r, y'all, yesterday we kind of solved some logs, and I think we had something like this. And remember, you had to isolate the log and you had to multiply both sides by 1/2. Do y'all remember doing that? Okay, that is actually an exponent. So when you have the log of a number in the front, that's actually an exponent of the argument. So that's x squared. So sometimes things are going to be raised to a power, and you're going to have to solve logs starting on Wednesday. So you can't solve a log with an exponent within an argument. That's too much. So we have to drop it in front. And what happens is that power becomes a factor. And we can certainly get rid of factors. We can just divide or multiply by the inverse. All right, so let's look at this example. We have ln of x squared divided by y to the third. So it's a division problem, which means when I write this in expanded form, there's going to be a minus sign. And y'all, these exponents, they just get dropped in front of the word log. That's it. So, or ln, which is the same thing as a log. So it is going to be 2 ln x. And then does anyone want to take a guess at the second piece? Yeah, minus 3 ln y. That's it.
Do you have to put the exponent in front, or could you still have it ln y cubed?
Look, according to the directions, I have to put it in the front.
But you wouldn't be, like, if that direction wasn't there, you wouldn't be wrong if you put it as like y.
No, I wouldn't care. However, listen, like we're just building up to solving. You have to put the power in front to solve it. So just get comfortable recognizing that that's a step you're going to have to take. On the next one, we have that. Y'all, what do logs always equal? Exponents, which means you can't have a radical. So if you see a radical symbol, you're going to have to rewrite that as an exponent. So I'm going to recopy log base 8. And then this x and that y, those are going to have exponents. What is the exponent that goes with y? I'm sorry, let me rephrase. What's the one that goes with x?
3/2.
Yeah, that's 3/2. And now the y. Yeah, good job. Are there any questions on that? Let's expand that out. Are you going to have a plus sign or a minus sign? Yeah, and guys, don't forget, you're not writing the word log first. The exponents come first. So it's going to be 3/2 log base 8 of x plus 1/2 log base 8 of y. And that's as hard as it gets for today. Do you guys have any questions? Okay, so here's my prediction. You guys are going to do the bottom on your own.